In the dimly lit corridors of artificial intelligence research, where the air hums with the faint static of neural networks and the occasional existential crisis, a new frontier is being charted. Large language models, those vast, inscrutable engines of text generation, are no longer content to merely mimic human speech. They are now attempting to mimic human thought. Not the shallow, surface-level kind of thought that gets you through a grocery list or a polite conversation, but the deep, meandering, occasionally incoherent kind of thought that leads to breakthroughs in mathematics, science, and philosophy. This is the world of long chain-of-thought reasoning, and it is as fascinating as it is unsettling. To understand what long chain-of-thought reasoning is, we must first understand its simpler cousin, chain-of-thought prompting. Chain of thought is a technique that encourages large language models to generate a series of intermediate steps when solving a problem, rather than jumping straight to the answer. It's like asking a child to show their work on a math problem, except the child is a billion-parameter neural network, and the math problem is something like, prove the Riemann hypothesis. Long chain of thought reasoning takes this idea and stretches it to its logical extreme. Instead of a few neat steps, the model generates an extended sequence of reasoning tokens, essentially a long, winding train of thought. This isn't just about producing more text. It's about enabling the model to explore multiple reasoning paths, backtrack when it hits a dead end, and even correct its own mistakes along the way. In other words, it's about making AI think more like a human, or at least more like a human who's had too much coffee and is trying to solve a particularly gnarly puzzle at 3 a.m. The research paper, Demystifying Long Chain of Thought Reasoning in Large Language Models, jumps face first into the mechanics of this process, and it's here that things get truly interesting. The authors identify several concepts that underpin long chain of thought reasoning. 1. Branching. This is the model's ability to explore multiple reasoning paths simultaneously. It's like standing at a crossroads and deciding to take every path at once, just to see where they lead. In the context of large language models, this means the model can consider different strategies or approaches to solving a problem, rather than committing to a single line of thought. 2. Backtracking. When a particular reasoning path turns out to be a dead end, the model can revert to an earlier point in the chain of thought and try a different approach. This is akin to realizing you've taken a wrong turn on a road trip and doubling back to try a different route. It's a necessary skill for complex problem solving, and it's one that humans use all the time, often without even realizing it. 3. Error. Validation and correction. Perhaps the most impressive aspect of long chain of thought reasoning is the model's ability to detect and correct its own mistakes. This is no small feat. It requires the model to monitor its own reasoning process, identify inconsistencies or errors, and take corrective action. It's like having an internal editor who's constantly looking over your shoulder, pointing out your mistakes, and suggesting ways to fix them. To put this in more human terms, you're trying to solve a complex puzzle, say, a Rubik's Cube. You don't just twist the cube randomly until it solves itself, which would be like spontaneously teleporting to Mars. Instead, you break the problem down into smaller, more manageable steps. You might start by solving one side, then move on to the next, and so on. Along the way, you might try different strategies, and if one approach doesn't work, you go back and try a different one. You might even realize you've made a mistake and have to undo some of your previous moves. This is essentially what long chain of thought reasoning allows large language models to do. The model generates a series of intermediate steps, a chain of thoughts, to solve a problem. It can explore different paths, backtrack if necessary, and even identify and correct errors in its reasoning. This step-by-step approach allows the model to tackle more complex problems that would be difficult to solve with a single, direct answer. By enabling large language models to engage in long chain of thought reasoning, we are effectively turning them into problem-solving partners. No longer are they mere text generators, spitting out answers based on patterns in their training data. They are now capable of reasoning through complex problems, exploring multiple solutions, and correcting their own mistakes. This opens up a world of possibilities for applications in fields like mathematics, science, software engineering, and beyond. For example, consider a math word problem. An LLM equipped with long chain-of-thought reasoning might first identify the key information, then formulate an equation, and finally solve the equation to arrive at the answer. This process of breaking down the problem into smaller steps is analogous to how humans reason through complex problems. It's not just about getting the right answer. It's about understanding the process that leads to the answer. The research paper acknowledges several potential limitations of long chain-of-thought reasoning. For one, the study relied on a relatively small sample size of large language models, which may limit the generalizability of the findings. Additionally, the study focused on a limited range of reasoning tasks, and further research is needed to assess the effectiveness of long chain-of-thought reasoning across diverse tasks. There's also the question of generalizability to other types of large language models. The study did not assess whether its findings apply to models with different architectures or training data. This is an important consideration, as the field of AI is constantly evolving, and new models are being developed all the time. And then there are the ethical considerations. As large language models become more sophisticated, we must grapple with the implications of creating machines that can think, or at least appear to think, like humans. What does it mean for society if AI can outperform humans in complex reasoning tasks? How do we ensure that these technologies are developed and deployed responsibly without stifling progress and limiting freedom using the old cudgel of fear? These are questions that will need to be addressed as we continue to push the boundaries of what AI can do. The research paper Demystifying Long Chain of Thought Reasoning in Large Language Models provides valuable insights into the factors that contribute to the effectiveness of long chain of thought reasoning in large language models. The findings suggest that supervised fine-tuning, increased training compute, scaling verifiable reward signals, and incentivizing core abilities are crucial for enabling large language models to generate long chain of thought trajectories. While there are potential limitations and challenges, this research has significant implications for the future of large language models and their ability to perform complex reasoning tasks. The road ahead is long and winding, but with careful navigation, it could lead us to a future where AI is not just a tool, but a partner in our quest for knowledge and understanding. And who knows? Maybe one day an AI will write an article like this one, only better.